The first thing you notice is the silence. Not the quiet of a stable, but the stillness of open land before a storm. Wind moves through tall grass. The sky hangs low and pale, and standing alone in that emptiness is a white shape, almost glowing against the earth. At a distance, it looks like a statue carved from ice. But as the camera moves closer, the illusion breaks. Its coat isn't smooth. It rises in hundreds of tiny, repeating patterns. Small rounded clusters packed tightly together. Like honeycomb, like coral, like something that belongs beneath the sea, not beneath the sun. And yet, this is a horse. In extreme cold, survival begins at the surface. Temperatures drop far below freezing. Wind strips heat from flesh like invisible fire. In these conditions, most animals rely on thick fur, simple insulation trapping air close to the body. But occasionally, nature does something stranger. Under certain genetic conditions, combined with prolonged environmental stress, a horse's coat can grow in dense, tightly clustered curls. Each curl compresses into a pocket of trapped air. Not random, not smooth, but structured, almost geometric. It's not honeycomb, of course, but it looks like it. These formations can resemble what scientists call felting and matting under extreme keratin overproduction, when hair fibers bind together, creating natural insulating clusters. Imagine thousands of tiny thermal domes covering the body, each one holding warmth, each one resisting wind. It's a biological response that feels engineered. But here's what makes it unsettling. Scientists still don't fully understand why, in rare cases, the pattern becomes so uniform, so structured, so eerily precise. Is it purely genetics? Or does prolonged environmental stress trigger deeper biological switches? Step further into the environment. This isn't a mild winter pasture. This is sub-zero exposure. Ice forming in the breath. Frost hardening on eyelashes. Water turning to glass. In such cold, the body faces a simple equation. Conserve heat or shut down. Most horses rely on fat layers and thick winter coats. But in extreme climates, like the open steppes of Central Asia or northern mountain plateaus, even that may not be enough. When hair fibers grow densely and curl tightly, they trap air more efficiently. Air is a poor conductor of heat. The tighter the pockets, the better the insulation. It's the same principle behind down feathers in Arctic birds, or the layered fur of musk oxen. But in this horse, the pattern seems exaggerated. Excess keratin, the protein that forms hair, thickens the strands. The curls compress. Over time, they interlock. From a distance, it resembles coral growth on stone, which raises a larger question. How far can mammalian adaptation go before it begins to look alien? Because this coat doesn't just protect. It transforms appearance. Move closer still. The texture changes how light moves across the body. Shadows fall into tiny valleys between clusters. The horse's musculature becomes obscured beneath a living armor of curls. Predators rely on silhouette recognition, movement, familiar shapes, but break the outline, and perception shifts. Some researchers suggest that unusual coat textures may offer subtle camouflage advantages in snowy or high-contrast terrain. Disrupted light reflection can soften visual boundaries. It's not invisibility, but it's distortion, and distortion can mean survival. Yet here's the mystery. If this adaptation is beneficial, why is it so rare? Why don't we see entire populations covered in honeycomb-like coats? Evolution usually favors what works. It spreads efficiency. It repeats success. Unless the trait comes at a cost. Perhaps the dense clustering traps moisture in warmer seasons. Perhaps it increases vulnerability to parasites. Perhaps it demands enormous metabolic energy to maintain. What we've discovered only deepens the mystery. At the microscopic level, each hair strand is built from keratin layered like overlapping scales. Under certain conditions, those strands twist more tightly during growth. The follicle itself can curve. The angle of emergence shifts. Multiply that across tens of thousands of follicles. The result isn't chaos. It's pattern. And pattern is one of biology's quiet signatures. Could the horse's coat be another example of self-organizing biology, a system following hidden mathematical constraints? Scientists still don't know why some follicles synchronize their curl direction so consistently, why the clustering becomes uniform instead of random, or why the effect intensifies in certain climates. It's as if the environment whispers to the genome, and the body answers in geometry. Layer 5, the illusion of the familiar. Stand back again. The white horse lifts its head. Steam pours from its nostrils. Wind moves across the strange, clustered surface. Snow collects between the curls but doesn't fully penetrate. For a moment, it no longer looks like livestock. It looks prehistoric, almost sculpted, almost engineered. And that feeling, that subtle sense of the alien, reveals something deeper about evolution itself. We tend to imagine adaptation as gradual, predictable, linear. But sometimes, when pressure builds at the edges of survivability, biology experiments, it bends. It exaggerates. It creates forms that blur the line between the expected and the impossible. And we are left staring at a creature we thought we understood. Seeing it for the first time. The unanswered horizon. This single horse doesn't rewrite evolution, but it reminds us that even familiar species carry hidden potential, dormant instructions waiting for the right environmental key. How many other adaptations are emerging quietly in remote landscapes? How many forms of life look ordinary until we look closer? Scientists still don't fully understand how extreme environments shape subtle genetic expression over generations. And if something as familiar as a horse can wear a coat that mimics honeycomb, what else is changing in silence? The wind rises again. The landscape stretches to the horizon. The white figure stands alone, patterned, resilient, almost otherworldly. And somewhere within that living geometry is a reminder. We have cataloged species. We have sequenced genomes. But the deeper logic of adaptation, the quiet conversation between climate and flesh, remains only partially understood. Out there, in the cold, evolution is still writing. And we are only beginning to read it.